Hello dear grade 9 students, welcome back to our physics classroom. We want to continue explaining the second part in chapter number 6 entitled AC voltage. At the end of this video, you will be able to define the period, the frequency and the amplitude of an AC voltage, calculate the different characteristics of an AC voltage, and you'll be able to establish the relation between the effective voltage and the maximum voltage in alternating sinusoidal voltage. Let's first of all recall the types of voltages. As you have known so far, we have two types of voltages, DC voltage and AC voltage. And also we have four types of AC voltage. We have the triangular signal, the bicycle signal, the alternating sinusoidal signal, and also we have the square signal. What are the characteristics of the alternating voltage? In fact, we have three main characteristics of alternating voltage. We have the voltage, the period, and the frequency. Let's first of all start talking about the voltage. The first characteristic of alternating voltage is the maximum voltage, given the vertical sensitivity SV equals 2 volt per division. This oscillogram refers to DC voltage since it keeps constant as the time varies. Now let us calculate the voltage at each point on this line. The displacement for each point is represented by y, where y equals 2.2 divisions. When applying the formula U equals SV times y, where SV equals 2 volt per division and y equals 2.2 divisions, it gives us 4.4 volt. So the voltage at each point on this line is 4.4 volt. And this is a logical result in the case of DC voltage since the voltage is the same on all these points. This explains why the oscillogram in the case of DC voltage is a horizontal luminous line. Is the same thing applied in the case of AC voltage? Let us see. We have a lot of points on this oscillogram. Let us deal only with this part by calculating the voltage at the maximum point and the minimum point and the points between. This is the maximum point and it has the maximum voltage. This is the minimum point and it has the minimum negative voltage. And this point is on the horizontal axis and it has 0 voltage. Let us prove this by calculation. The amplitude or the maximum displacement of this point is given by y, where y equals 3 division. When applying the formula U equals SV times y, it gives us 6 volt. So the voltage at this maximum point is 6 volt. Let us move to this point. The displacement of this point is given by y, where y equals 2 division. When applying the formula, it gives us 4 volt. At this point, the displacement is given also by y, where y equals 1 division. When calculating the voltage, it gives us 2 volt. At this point, y equals 0 division, so the voltage is 0. Now let's move to this point. Y here is equal to minus 1 division since it is below the axis of time. When applying the formula U equals SV times y, it gives us minus 2 volt. Also at this point, y equals minus 2 division, it gives us minus 4 volt. Now at this point, y equals minus 3 division. When applying the formula, it gives us minus 6 volt. As you see, the voltage in the case of alternating voltage alternates between the maximum positive point and the minimum negative point. Here we are not concerned about calculating the voltage at each point. What we are concerned about is to calculate the voltage. So let us move to see how to calculate the maximum voltage in the case of alternating voltage. Given the vertical sensitivity is equal to 2 volt per division, we have to find the maximum voltage. Here, the amplitude of the peak point or its maximum displacement from the horizontal axis of time is represented by y maximum, which is equal to 1, 2, 3 divisions. And since the SV is equal to 2 volt per division, this means that every vertical division holds 2 volt. So the maximum voltage is 2 plus 2 plus 2 equals 6 volt. Or we can calculate the voltage the other way around, since we have 3 divisions and each division holds 2 volts. So we multiply the number of the divisions by the voltage, which is 2. Then we get 6 volts. So U maximum is equal to Y maximum times SV. This is the rule to be memorized. Let's now move to the second characteristic of the alternating voltage, which is the effective voltage. Here we have a wall outlet of AC voltage. When it is connected to a voltmeter of AC mode, this voltmeter reads 220 volt. When this same outlet is connected now to the oscilloscope gives us 310 volt. So we have 2 types of voltages right here. The first one is called the effective voltage, while the second one is called the maximum voltage. The effective voltage is measured using the voltmeter, while the maximum voltage is measured using the oscilloscope. Now we want to talk about the characteristic of the period. Given this oscillogram, the part of this oscillogram in red constitutes a cycle or an oscillation. It starts with the 0 level, it increases to the maximum positive point, it drops to the 0 level and drops more to the minimum negative point and goes back to the 0 level. Now we want to calculate the period of this cycle or this oscillation. The number of divisions of this oscillation is represented by X. X here is equal to 1, 2, 3, 4 divisions, or we can calculate the number of divisions from the crest to the crest or from a trough to a trough. So the period T is defined as the time for one oscillation to repeat itself. Given VB or time base is equal to 10 milliseconds per division. So each horizontal division holds 10 milliseconds. So the time for this cycle is 10 plus 10 plus 10 plus 10, which is 40 milliseconds, or we can calculate it the other way around. The number of the horizontal divisions for one cycle multiplied by VB. Then we get this formula, period T is equal to VB multiplied by X, or the number of the horizontal divisions for one cycle or one oscillation. Now we want to talk about the frequency characteristic. The fourth characteristic of alternating voltage is the frequency. The frequency is defined as the number of oscillations in 1 second. Here we have one oscillation. It starts from the 0 point, increases to the maximum positive point, drops to 0 level and drops more to the negative minimum point and back to 0 level. The period of one oscillation is 0.25 seconds in this example. Now I want to calculate the number of the oscillations in 1 second. It means from this point to this point. So we have, this is one oscillation, this is the second oscillation, this is the third, and this one is the fourth oscillation. So we have 4 oscillations in 1 second. And according to the definition, the frequency is the number of oscillations in 1 second. So the frequency is equal to 4. Now divide 1 over the period. In this example, the period is 0.25 seconds. It gives us 4. So we can conclude that the frequency is equal to 1 over T. The unit of the frequency is Hertz, under a condition that the period must be in seconds. So when the period is in millisecond, we have to convert this millisecond to second by dividing by 1000. The second particular characteristic of alternating sinusoidal voltage is the effective voltage. In this example, we have 3 AC generators of different sinusoidal voltages. We have generator A, B, and C. The maximum voltage for the first one is 100, for the second generator is 200, and for generator C is 300. This maximum voltage is measured using the oscilloscope. Now the effective voltage of each generator is given by 72, 142, and 214 respectively. This effective voltage is measured using the voltmeter. Now let us divide the maximum voltage over the effective voltage. We notice that each division gives us the same number, which is 1.4. Since U maximum over U effective gives a constant number, which is 1.4, we can infer this formula. U maximum is equal to U effective multiplied by 1.4. 1.4 is approximately equal to radical 2. Then we can infer another rule. U effective is equal to U maximum over radical 2. This is to be memorized. But keep it in mind that if U maximum over U effective is not equal to radical 2, then this voltage is not an alternating sinusoidal voltage. Let's solve this application. We have to answer the questions below. Given this oscillogram, identify the type of the voltage. This voltage is alternating sinusoidal voltage since it alternates successively between positive and negative values. What do 5 volt and 10 millisecond indicate? 5 volt is the vertical scale that corresponds to SV, and 10 millisecond is the horizontal scale that corresponds to VB. Indicate the number of the cycles. Here we have one cycle. This is the second, and this is a half cycle. So the number of the cycles or the oscillations is 2.5 oscillation. We have to indicate Y maximum and X. Y maximum here is equal to 2 divisions, while X here is equal 1, 2, 3, 4 divisions. Now we have to calculate the maximum voltage by applying the formula U maximum equals SV times Y maximum. SV is equal to 5 volt per division, while Y maximum is equal to 2 division. It gives us 10 volt. Now we have to deduce the effective voltage also by applying the formula U effective is equal to U maximum over radical 2. It gives us 8.3 volt. Now we have to calculate the period. Period T, it is equal to VB times X. This is the VB 10 millisecond per division, and X is 4 divisions. It gives us 40 millisecond. And finally, we have to deduce the frequency. The frequency F is equal to 1 over period under the condition that the period must be in seconds. So it is equal to 1 over 0.004 seconds. It gives us 25 Hertz. Application number 2, choose the correct answer. The voltmeter connected to an AC voltage power supply measures the effective voltage, the average voltage, or the maximum voltage. Of course, the voltmeter measures the effective voltage. Now, the oscilloscope connected to an AC voltage power supply measures the maximum voltage. An alternating sinusoidal voltage of effective value 10 volt has maximum voltage. We have to apply the rule here. U maximum is equal to U effective multiplied by radical 2. It gives us 14.14 volt. Part 4. A voltage of period 2 millisecond has a frequency. Also here we have to apply the formula F equals 1 over T in seconds. It gives us 500 Hertz. Part 5. If the maximum voltage is 220 volt and the effective voltage is 157 volt, then the type of the voltage is. When we divide the maximum voltage over the effective voltage, it gives us radical 2. Then the type of the voltage is, of course, alternating sinusoidal voltage. To sum up the characteristics of the alternating voltage, we have U maximum is equal to SV times Y maximum. U maximum is measured using the oscilloscope. The effective voltage is measured using the voltmeter. The period T is equal to VB multiplied by X. The frequency is equal to 1 over T. And this characteristic is specific for sinusoidal AC voltage. U maximum is equal to U effective times radical 2. And finally comes the assignment. Solve the applications again, memorize the summing up, and solve exercises 12, 13, 14, page 81 on your book, and then solve the extra sheet. Thanks for watching us and have a nice day.